St. Joseph's College for Women, Autonomous, Vishakhapatnam. Welcome to St. Joseph's open web-based learning platform, So E-Learn, for a soulful and enriching e-learning experience. Department of Physics presents SMOOC, St. Joseph's massive open online course.
I am Dr. P. Padmavati Devi, working as Assistant Professor in the Department of Physics in St. Joseph College for Women, Vishakhapatnam. Good morning, students. Today, my class is for 2nd BSc, 3rd semester, Physics. Today, I am going to discuss the 5th unit, Lasers and Holography. What are the main components of a laser? First one is an active medium, the second one is a pumping source, and the third is an optical resonator. So what is an active medium? The medium in which produces the laser beam, or we can say where the population inversion is achieved, is called as an active system. Next comes the energy source. The source of energy is used to raise the atom to an excited state. We have seen in the previous class how the atom is raised to an excited state in absorption of radiation, spontaneous emission, and stimulated emission. The third one is the resonator activity. It consists of two mirrors facing each other. One is fully reflective while the other is partially reflective. The main function of the optical resonator is to increase the intensity of the laser beam. So let's see the construction and working of a ruby laser. The ruby laser was first created in the year 1960 by Th. Maiman. See in the figure, a ruby laser is a 3-level solid-state laser that uses a ruby crystal that acts as an active medium where the population inversion is achieved. In a ruby laser, a cylindrical ruby rod made up of aluminum oxide is doped with 0.05% of chromium oxide. These chromium ions give the crystal a pink or a red color. The crystal, the blue color, is surrounded by a xenon flash lamp that acts as a pumping agent. So to reduce the temperature, cold water is added, surrounded by the flash tube which has a xenon gas. Both the ends, E1 and E2 of the crystal, are properly polished. One end of the rod is fully silvered and the other end partially silvered. So it acts as an optical resonator. So whenever we pass current through this arrangement, a laser beam of red color having high intensity will come out. Let us see the working of a ruby laser. In the figure, E1, E2 and E3 represents the energy levels of chromium ion. In normal state, the chromium ion is in lower energy level E1. When the ruby laser is irradiated with light of xenon flash, the chromium atoms are excited to the upper energy level E3. So the chromium ions, after staying up for 10 to the power minus 8 seconds in the excited state, they get transmitted to the metastable state. Because the lifetime of the chromium ions in the excited state is only 10 to the power minus 8 seconds. After 10 to the power minus 8 seconds, it falls back to the E2 level. That is nothing but a metastable state. As E2 is a metastable state, so the chromium ions will stay for a longer time. So the number of chromium ions goes on increasing in the E2 state. But due to pumping, the number in the ground state E1 goes on decreasing. So few of the chromium ions will come back from E2 to E1 by the process of stimulated emission by emitting photons, which results in the amplification. So this stimulated emission is in the laser transmission of ruby laser. So the laser radiation of the wavelength of a ruby laser is 6943 angstrom is pulsed out. Applications of ruby laser. Ruby lasers are used in laboratory experiments, used for soldering and welding. It is also used to drill fine holes in a brittle material. It is used in light detection and ranging applications. LIDAR is a remote sensing method that uses light in the form of a pulsed laser to measure variable distance to the Earth.
All the images in this video has been taken from open education resources. Thank you.